Alright, so I'm going to do the next four. Hopefully I don't butcher any of these. There's some tough problems in here. What is the value of 6/9 of 30/40 of 44/55 of 200? So really, we're just multiplying all these numbers together. So essentially we're saying, oh, that's my hidden square covering everything else. So I have 6/9 times 30/40 times 44/55 times 200 over 1. All right, well, obviously I noticed that I can reduce a lot of these. 6/9 reduces to 2/3. 30/40 reduces to 3/4. Oh, I see it. I like it. I like it. 11 goes into both of them, so that's 4/5. Ooh, even better. And we have 200 over 1. So I'm hoping that your teachers have talked to you about cross-reducing things. In other words, before we multiply things out, and I don't want to multiply all these things out and then reduce. That'd be ridiculous. We know that if we have a 3 in the denominator and a 3 in the numerator, even if it isn't in the same fraction, and we're multiplying them or dividing them together, we know that 3 divided by 3 is 1, so that cancels out. 4 divided by 4 is 1, cancels out. So really, all this problem is asking you to do is doing 2/5 times 200 over 1. Well, 5 goes into 200 40 times, again cross-reducing. 2 times 40 is 80. All right, number 8. Find the least number for which all the following is true. The number is greater than 300. I'm not going to do anything with that right now. We know it's greater than 300. If it is divided by 3, the remainder is 2. Well, I know that 302 works, right? So then 3 more than that would be 305, 308, 311, 314. I'm going to slide this over a little bit. 317, 320. I'm going to stop there, and if we need to go on, we will. So then the next line says, it is 2 more than a multiple of 4. Well, 300 is a multiple of 4. So 2 more would be 302 again. 4 more is 306, 310. Right now 302 looks promising. I'm going to go through the whole thing. 314, oh, that looks promising too. 318, and let's go 322. All right, so we have 2 possibilities. We have 302 and 314. Then the last one says, if it is 1 less than a number divisible by 5. So that would be 304. Well, so that's out. 309, 314. We have a winner. It's 314. It complies with all 3 of those. All right, the figure shown consists, this figure, consists of 2 large congruent squares whose sides each have a length of 10 units. So this is 10. And 6 small congruent whose side lengths have length of 3. So this whole thing, 1, 2, 3, 4, 5, 6. So that's 6 times 3, which is 18. Oh, well, so this has to be 8. Well, it's a square, right? All right. So 8 times 8 is 64. Because length times width is the whole area. All right, that wasn't too bad. Last one. A store sells shirts at 3 prices only, 25, 30, and 35. Before I go any further, I noticed something about that. what do you notice about these three numbers? And these competitions are all about making quick connections. Well, I notice that 25, 30, and 35, they're all an average of 30, because 25 is 5 less than 30, 35 is 5 more than 30. So how many different combinations is it possible for the store to sell 20 shirts for a total of $600? Well, let's do the first question. So we need 20 shirts for a total of $600. Well, just for funsies, if I have $600 and each shirt is $30, well, that's going to be exactly 20 shirts, right? So there's one combination. So if all of the shirts are $1, that is exactly 20 shirts. Great. Okay, so then so the next thing, what happens, so that's one combination, at all $30. Incidentally, did you know that the dollar sign is really just US? And then we've dropped that part here to have the two lines through. Isn't that kind of interesting? All right, so then the next thing I can do is I could have one cheaper one. I can have 18 $30 shirts and one, and that's still 20. And this plus this gets me to my average of 30. Oh, all right. So then I can do 2, 16, 2, 3, 14, 3, 4, 15, 4, 5, sorry, not 15, that's a 12, 10, 6, 8, 6, 7, 6, 7, 8, 4, 8, and I could have 9, 2, 9, and finally 10, 0, 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can have 11 combinations.